Good morning to all. I welcome you for the lecture series in production technology. As we already discussed in the class, what is measurements and what are the instruments we have in the previous lecture. Today, to the continuation of the previous lecture, we could see something called as error, right? So repeating something wrongly, that is what repeating something wrongly is nothing but error. So when we go into the error, measurement error refers to the difference between a measured value and the true value or the accepted value. No measurement is perfectly accurate due to various factors. Understanding the types and source of error is crucial to interpreting measurement results correctly. So you could understand something about this measurement error. We have a nominal value that has to be achieved through a drawing for a component. So in that, when you measure the value of the component which is produced based on the drawing, the measured value may not be same as the true value or the accepted value, and there may be some difference. And the difference out of the tolerance zone, we call it as error of any measurement. So what is error in measurement? We can classify this error in measurement. The definition of error is the difference between actual measured value and the true predetermined value. The classification of error in measurement features three main categories. One is systematic error and random error, limiting and gross error. So let us see into the errors in depth. Systematic errors. These errors are consistent and repeatable, often caused by faulty equipment, improper calibration, or flawed methods. They can be corrected by adjusting the measuring instruments or using proper techniques. Misalignment of instruments, incorrect zero setting. So these are the two examples we can take for a shaft. That is, we are going to measure. Whenever you are measuring a shaft diameter, so you can use either a vernier caliper to determine the outer diameter of the shaft, or else we can use steel rule for getting the outer diameter of the shaft. So these two instruments, without using this, and if you are using some other instruments or faulty equipment or faulty setting of the workpiece in the table, and we can get this systematic errors. So improper calibration is one of the major cause for systematic errors. Let us see what is calibration. Calibration is nothing but checking the standards of the instruments with the uh, set standards that is maintained in Geneva, right? So we often use measuring instruments repeatedly. This may cause damage to the measuring instruments, and the precision or the correctness of the instrument is being reduced over a period of time. So every instrument will have a calibration procedure so that we can go for calibration and check the instrument whether it is having a zero error. So then we can go for one more cause for the systematic errors is flawed methods. So whenever you go for a particular process sequence, you should not use flawed method that produces a defective workpiece, which may lead to systematic error. So incorrect zero setting is one of the another example we can take. So always whenever we use any instrument, the zero setting should be properly checked. Otherwise, it will add up to the measured value and it will show some errors in the measurement. So coming to the random errors, these occur unpredictably or caused by uncontrollable factors such as slight fluctuation in experimental conditions. So as the name indicates, random is nothing but we cannot predict anything that is happening during the measurement. And there may be a slight fluctuation in experimental conditions. They are harder to eliminate, but can be reduced by averaging multiple measurements. Temperature fluctuations, human reaction time. So these are the two examples for random errors. And gross errors, these are large mistakes caused by human errors, such as misreading a scale or using wrong instrument, recording incorrect data, wrong experimental setup. So we have something error called parallax error. Whenever you read an instrument a scale, the eye should be parallel to the instrument. Otherwise, there may be a mismatch of reading the measured value. So advantages, it helps identify limitations, accuracy, provides data for uncertainty analysis, encourages better equipment calibration. Disadvantages of error in measurement, it reduces accuracy, time consuming and misleading results. So errors in measurement are inevitable, but still we have to categorize all the important critical values that is being mentioned in your drawing, and the proper usage of instruments has to be made so that we can avoid errors. So what are the key properties that has to be studied in errors is nothing but precision, consistency of repeated measurements, repeatability, consistent results under the same condition, reproducibility is another word, similar results across different setups, resolution, smallest detectable change, and sensitivity is ability to detect small variations. Linearity is direct proportionality between input and output. Range spans between minimum and maximum value of measurable things. So thank you all.